You should have a paper that looks like this to fill in while I go through this presentation. We're going to talk about coal, oil, and gasoline, natural gas, hydroelectric, nuclear, and then on the second page, biomass, solar energy, wind, waves, tides, geothermal, and hydrogen. The first one to fill in your chart is coal, and coal is mainly used for electricity and to power machines in factories, but primarily for electricity. And in the United States, coal is about 40% of our electricity comes from coal. You should write that down. So 40% of U.S. electricity. This number has come down, which is good because coal is particularly dirty. It has come down from 50% to 40% in the past several years. So how is power generated? Well, most of the time they light the coal on fire and they have some water and it boils and creates steam, and the force of the steam with pressure spins the turbines. And turbines spin so quickly that generators release electrons that are attached to the turbines. And so they're magnets inside of the generators that will release the electrons. And all electricity is electrons. So we have industrial smog, acid rain, mercury pollution, and global warming from the CO2. Our human health problems are air pollution, such as respiratory problems, such as asthma, and then other things that are also human health problems. So coal also contains mercury, and when it's burned, it goes up into the atmosphere, and then rain brings it down to land where it flows into the ocean in rivers. And then it goes up the food web with bioaccumulation and biomagnification until it gets into your top predatory fish like tuna. And you should know that from chapter 14. And also there is a specific type of problem from mining. So the miners end up getting black lung disease from all of the dust they breathe in as they're mining it. The U.S. and China have the most coal and use the most coal in the world. The next energy source you need to know is oil, and sometimes it's called crude oil or petroleum oil. And we take that and we refine it into gasoline and diesel and butane and propane and a lot of other products, including plastics actually. But the majority of it is turned into transportation fuel. I've heard a number about 10% goes to plastic. I'm not quite sure if that is the accurate number. And then in some places where they have a lot of oil, like Saudi Arabia, they will burn that to generate electricity. But that's rare. The majority of our oil is for transportation, cars, planes, boats, etc. So we have the internal combustion engine, which was featured in chapter 18. So that's a review term. So basically to combust means to light it on fire, and then it runs the engine that way. There's some specific problems with oil. The biggest one is habitat fragmentation from building roads to the drilling site. These are all oil drills, FDR oil wells. And building the roads to access them can cause habitat fragmentation, especially up in the Arctic. And then we also have photochemical smog that we have in Los Angeles and Santa Clarita. Respiratory problems such as asthma, that's the biggest one. So U.S. uses the most, and then these guys have the most, but I'm going to add something here. So I just heard a story that the U.S. is about to become the top oil producer. So not yet. So on your AP test, pick Venezuela or Saudi Arabia or Russia as your top oil producers, but very soon we may become the top oil producer. And that has to do with new technologies where we can extract oil from places that we could not before, like oil shale, some fracking methods. Now, fracking we always think of with natural gas, which is true, but also we can do fracking with oil as well. The next one is natural gas. So natural gas is used for a lot of things. In your homes, you probably, or you might cook with it, although some people have electric stoves. Most of you will have your heater as natural gas. In California, most of our electricity comes from burning natural gas. When I say most, it means the highest percentage, but we do have a lot of hydroelectric power in California from all of the mountains that we are able to dam the valleys and create hydroelectric power. We also have a lot of wind and solar and some nuclear, but the highest percentage of our electricity in California comes from natural gas. And they have also developed cars that run on natural gas. In Santa Clarita, our buses run on, if you've ever noticed, there's this little symbol on the bus on the back that says CNG, which stands for clean natural gas. And so our buses run on natural gas, which means that they don't pollute out the exhaust pipe. So that's not all of our buses, but most of them run on clean natural gas. So we basically burn it. We boil water, steam spins turbines, which generate electricity in the generators. And then that's for electricity, but then we just light it on fire for cooking, like at our stoves, for heaters, or for transportation. So our environmental problems, we've had a couple of exploding pipelines which have killed people in the past. We do have some carbon dioxide for global warming from natural gas. It's not as bad as the other two fossil fuels, so it's the cleanest of the fossil fuels. But fracking is a problem because it can contaminate your aquifers. It is a toxic gas. We add a smell to it so that if you have a natural gas leak, you know, and you're like, that smells like gas. And we put that smell in so that people will recognize that they have a gas problem and they call the gas company. And then the United States and Russia lead the world in the production and the consumption of natural gas. Next one is hydroelectric. Sometimes it's called hydropower. It is renewable if there's enough rain. Some of our hydroelectric dams in California had to shut down because there wasn't enough rain and the reservoir wasn't full enough to actually go through the dam to spin turbines. So electricity is really here. This is once the dam is built and paid for and the cost of it has been paid back, it's cheap energy. You just run water through the dam to spin turbines. We also, in the lakes behind the dams, we have water storage. So water spins the turbines in the dams. Pretty easy there to generate the electricity. When we have this big pile of water, these lakes that we develop behind the dams, these reservoirs, we can cause more evaporation and lose that water. And then we alter the habitat. So we turn a river into a lake, and so the species are going to change. The river species are going to decline, and your lake species are going to increase. Also sediments. So sediments come down rivers naturally, and then they build wetlands before they go into the ocean. In a lot of places, like the Mississippi River and like places in California. Without those sediments, number one, the wetlands cannot be replenished. And number two, they build up behind the dam and then they have to be dredged out. In tropical countries, one of the problems is mosquitoes. So you have this big pile of sitting water, which can breed mosquitoes. We don't have that problem with our dams in California. But in tropical countries, that's a problem. So mosquitoes like sitting water, not running water. And so you take running water in a river and you dam it, and now you have sitting water. So here's some interesting stats to know. So Norway produces the highest percentage of their own electricity from hydropower or hydroelectric. Canada produces the most megawatts of power in the whole world. So these are places with a lot of mountains and valleys that you can dam the river in the valley. And then China has built the largest dam, which is the Three Gorges Dam in the world. The next one is nuclear power. So nuclear power is used for electricity, for weapons, for naval ships. And the power is generated. You need to know that they use uranium-235 specifically. So that is the isotope used in electricity, weapons, and naval ships. So basically, power is generated. We don't actually burn the uranium, but we bombard it with protons to then start a chain reaction to then release the energy. So as soon as an atom splits in half, the uranium atom divides, and it releases a lot of energy and heat. And that heat will then boil water, which the steam spins the turbine. So it's the same concept. So we have accidents, and where are we going to put our spent fuel rods? And then thermal pollution can occur from cooling down the water to be reused again. So specifically, when there's an accident that lets out radiation, you have specifically thyroid cancer. So don't just write cancer on an FRQ. You have to know specifically it's thyroid cancer. Leukemia, birth defects, radiation poisoning, all of those things can happen. And again, that's only with an accident. If you live near a nuclear power plant and there aren't any accidents, then it's not going to cause these problems. France produces something like 70% of their own power from nuclear, so they produce the most percentage of their own power. The United States creates the most megawatts, so for us, it's only about 19 to 20% of our own power, where France, it's 70% of their own power. But we're a bigger country than France. We have more people, and so our 19 to 20% is more power than France's 70%. And we'll continue on with the next video.